right, well, let me just begin by introducing myself. So, my name is Linje Boston, and first I want to just say thank you to Maria and Violina and Anna for allowing me to speak with you today. I'm very excited to kind of talk a little bit about how I view data and analytics and kind of the disciplines within it. And my hope is that, at the end of this presentation, you'll be more familiar with some of the different titles and tasks and what they do. And when people talk about different things like what is a data engineer, what does he do, when we talk about data and analytics. So with that, let's begin. All right, so first about me. So just some quick facts. So I went to college and I went to college and grad school, and for both of those, I studied statistics. And it's funny because whenever I say statistics, a lot of people always say, "Oh my gosh, I hated statistics. It was a horrible course for me." But the reason I like statistics so much is that it allows me to play in a lot of different fields because a lot of different fields are touched by data. So as long as you're talking about data and you want to try and draw some meanings from it or understand what's happening, then statistics is a great field because you can talk about data about sports or data about businesses or data about the weather. It's kind of all, a lot of those things can kind of be reused, even though the fields change. So that's why I like statistics so much. I have been a consultant for 18 years. That's a long time, if you ask me. It's funny because I think about, I'm down here, my first job was actually working with my sister, but my first job was as a consultant. I had the pleasure of working with my dad. He had a consulting company, and so me and my sister had many. We learned a lot. We had many kind of different little battles. I say battles, but I'm kind of joking. Like we kind of butted heads over the company and different things like that. But we had a great time. We learned a lot of it. We learned a lot of good stuff about how to be good consultants. And originally the consulting company was kind of like an econ consulting company. So we studied a lot of different business and business factors, things like that. But I like to consider myself a data detective. So I kind of use that word. Let me kind of define what that means. Like when I look at data, I kind of look at it as like, I kind of think of it as like it's a mystery to be solved, meaning there are like underlying patterns or features of the data. And I like to just dive in there and kind of uncover all this stuff. And that process is very, very, it's very rewarding for me. I like being able to ask questions and then try to answer those questions with the data that I've been presented. So that's what I consider a data detective, and that's kind of how I view myself, basically. And then hobbies. So I like to play bass guitar and I like video games. And my favorite places to visit are Jamaica. Well, these are just limited, but I like the Caribbean. So Jamaica, and my wife's from Jamaica, and then Bermuda as well. Those are some of my favorite places. All right, so let's kind of get into the meat of it, right? So these are the kind of the disciplines as I see it, that when people say data analytics, they're usually talking about something in one of these five kind of disciplines. And we're going to talk about each of these in more detail later, but this is kind of just the overview of what we'll be talking about today. So with that, let me go to my next slide. All right, so first, what is data? So I got this definition from Gemini, but I like it a lot. Gemini is kind of like you probably don't know what Gemini is, so you guys are using it already. But in any event, so the definition is data refers to facts, figures, or information that can be used for analysis, reasoning, or decision making. So I like the definition a lot. I think it's very flexible, kind of makes sense to me. Basically, actually, that's fine. I think we'll just leave it there. So how is data represented? Like what is data? What can data be? What is it comprised of, right? So data can be numbers, it can be text, it could be pictures or images, it could also be audio, right? So so this is kind of just like the components of what constitutes data, what you can store. And then here on this slide, I kind of have the different formats. These are not all the different types of formats of data, but these are just some of them. This is just a limited list. But you have like text-based format. So when I say like a format of data, like this is kind of like just the storage format, right? So you have like CSV files or JavaScript object notation, oh boy, I can't remember what the acronyms for JSON is. XML, markup language, NI. These are like configuration files. These are just text-based formats. And you have binary formats with PDFs or images, JPEG. I'm sure as front-end developers, you guys probably know a lot more about these than I do. And then you have databases. So databases, when I think of database, they store data they can be structured or unstructured. But for the most part, a database will store data in its own type of format. So you'll have like SQL databases, of which an example is MySQL. You can have NoSQL databases, of which an example is like a MongoDB, and you can also have key value store. There are many, many different types of databases. I'm not trying to go into all of them, but the idea is just that, different ways of storing information or data, basically. And then we also have Excel. Excel is another format with which we can store information or data. Let's keep going. All right. So what am I trying to accomplish with this slide? So when I think about digital data storage, which basically means storing data on computers, that's what I'm kind of trying to hint at. I kind of have a very crude kind of hierarchy of kind of as how I understand it, right? So especially when you're talking about a lot of data, you are usually hitting up some type of database, or you're storing it in some type of file system, right? So let's start with the left side first. So basically, under databases, you kind of have relational databases, you have not just SQL databases, and you have hierarchical. So let's talk about each of these in turn. So relational is kind of like the standard format of a database, like tables and fields in the table, or columns in the table. And you kind of have you can have like a star schema. That's kind of, we'll talk about that in a minute. But the idea is just relational databases is like tables and fields in those tables, basically. And then not just SQL. So like an example of that is like a Mongo database. So basically you're using like documents. So the thing is that the major difference between these things is that the NoSQL databases give you much more flexibility in terms of storing your information. So whereas, with your relational database, you kind of have to have you have your fields and you have your tables thought up ahead of time. In a not just SQL database, you're working more with documents, and documents they can be kind of ragged. Meaning, when I say ragged, I mean to say that they don't necessarily have to have all the same fields or values for all the fields for all the different documents, if that makes sense. Okay, and then hierarchical. So hierarchical is kind of like a database is organized in a tree-like structure. And then other versions of a not just SQL database are like a document, which I kind of talked about, which is MongoDB, or a graph. So if you think of a graph database, that's like what powers like social networks, right? So you can have a lot of different connections between different points in your database, the different data points. So, like a LinkedIn or Facebook, they're running based with big graph databases. All right, then we come over here to the file system. So remember, it's either a database or a file system. So what's a file system like? You kind of have you have three different versions as I see it. You kind of have it in the cloud, you can have it on premises, or you can have it local. So cloud, like an Amazon, like S3 bucket, which stands for simple server storage. It's basically just a file folder in the cloud. On premises, so Hadoop distributed file system, that's just a big data set. That's like a big data file system manager, basically. Holds a lot of information, but it's on-prem. And then local, like NTFS. So this is just like your Windows machine, basically. Like you can pull it from your Windows machine. Maybe sometimes you're like pulling data and you need to stitch something together, and you make something on your local machine, and then you're going to upload it into a database, or you can upload it into a file system, whatever. But that's another type of file system. All right, let's keep going. All right, so now we're kind of getting into the meat of it. So now I'm going to begin my conversation about these different aspects within data analytics. So data architecture, right? So what is data architecture? Who practices data architecture? So first, the purpose of data architecture is to design and management of systems that are efficient at storing and retrieving data, right? So basically, data architecture is performed by data architects. Very simple, right? And the kind of thing is like, when you think about data, especially if you're looking at it as a business, then you're either trying to design a system that stores information or stores data quickly or efficiently, or retrieves data efficiently, basically. So it's kind of one or the other for the most part. And so when I think of a data architect, I really think of like a designer. He's like designing the system. He's using his knowledge of different tools and expertise to design a system that's efficient at, storing or retrieving data. So what is he doing? Well, I should say this. What is she doing, right? So basically, she's going to go in and start modeling, like he's going to design your different databases, how the tables in your database should be structured, or how the tables in your data warehouse should be structured. What is she also doing? She's going to be efficient at integration. So that means pulling data from different sources into one place. So maybe some of your data is in the cloud. She's gonna say, okay, I got to go to the cloud, pull this down. I got to go to the on-prem or on-premises server and pull this down and kind of tie it together and put it into one place so that you can do some analysis with it. Also, she's going to be good at security and privacy. So the idea is that you have regulation that governs, the protection of sensitive data. So, and then finally, governance, right? And we'll talk about governance because that's another aspect of data analytics. But the idea is that, with governance, you can accomplish many different things. But in general, you want to make sure that, your data is of high quality and is compliant with regulations for using that information. So then finally, we have some of the skill sets. What are the skill sets for a good data architect? So she should be able to transform business requirements into technical solutions. So that means, interacting with the business and being like, okay, well, they need a system that can do X, X, and Y. So I'm gonna pull these particular tools together. They need to be, or the data architect needs to be capable of leading data teams and can solve many different data-related problems. So that's kind of the data architect at a high level. Again, I'm keeping everything at a very high level. We won't get into too many details, but in any event, let's keep going. So data engineering. So what is data engineering? So if the data architect is like the designer, the data engineer is essentially the person that builds the design, right? Builds out the design that's been given to them by the data architect, right? So a lot of it is a talk around like pipelines that enable collection and storage and processing. It's basically like just implementing the plan that's been given to them from the data architect. They do other things as well. They have a lot of stuff around maintenance and upkeep and things like that. But let's talk about the responsibilities of a good data engineer. So a good data engineer should be able to gather data from different sources like APIs or databases or streaming platforms. There also should be good with accessibility. So what does that mean? So a good data engineer would be able to source and transform data later for analysis. So they're going to work with a data scientist, and the data scientist is going to say, hey, can you transform this data so that I can suck it into my model so that I can do some predictions, right? So the accessibility, when I say accessibility, essentially what I'm talking about is this idea of like being good with manipulating data and being able to apply transformations, mostly using SQL or whatever, using query structure to allow you to transform the data so that you can give it to whoever needs it in whatever format they need it, basically. So we talk about pipelines. So we talk about a lot of ETL, which basically means extract, transform, load. So basically you're taking it from someplace, you're applying some transformations, and you're loading it to someplace else, to another storage location. And then finally, governance, right? So a good data engineer is going to always be aware of like governance. So that means like ensuring the data, you have data quality and compliance. Oh, is there? I thought there was a question. Okay. And then finally, so the skill set, right? So they got to have the technical know-how to implement the data architect's design. They should be good with ETL tools and capabilities and can learn new technologies quickly, right? So that's kind of the data engineering aspect as I see it. Again, this is kind of all from my just experience in working in this field. So that's why that's what I think about when I think of a data engineer. And let's keep going. All right, data governance. So data governance. It's interesting because it's kind of often overlooked in data and analytics, the importance of data governance, right? But I can tell you from my experience as a consultant that there's a drastic difference in a company's capability of using data effectively to drive data-driven decisions. And it depends a lot on how well their data governance architecture or structure is in the company, right? So this is data governance is own broad, huge topic, but as I'm trying to reduce it down, I see this kind of like this. The purpose is basically to ensure accuracy, consistency, security, and quality of a business's data, right? And so as earlier, if we talk about a data architect does data architecture work, a data engineer does data engineer work. For data governance, we call them data stewards. And a data steward is basically the person that understands where the data is coming from, what are the implications for how it's been maybe transformed, and then ultimately how you should use that information, right? So a good data steward really saves you a lot of time because she saves you a lot of time because she's able to kind of tell you, to kind of save you a lot of time with discovery. So if you're trying to take this data and do a bunch of work, she's going to tell you, look, if you want to use this data for this purpose, you could pull these particular fields, and they're going to give you the answers that you need, basically. So they kind of have this knowledge about the data that they are responsible for, essentially. So what are some of the responsibilities of a good data steward, right? So they want to ensure completeness, accuracy, and timeliness. And, accuracy, accuracy, they want to make sure the data is accurate. That makes sense. Completeness is that if there are gaps, like sometimes, you're at a business and like they have, let's say a business has, company in Australia and the United States and also Bulgaria, right? And let's say that some of the information is incomplete from the standpoint of like there are gaps in the data, right? So maybe in this, at the consumption layer. So what I'm basically saying is like when it's all put into like a data warehouse, when it's centralized, all this information, they could say the data steward would say like, okay, well the information from the United States is missing on some of these particular fields, so we don't capture that information. So a data steward is going to tell you where it's complete and where it's incomplete, which is very important for you to know because you don't want to draw conclusions from incomplete data. That's very dangerous, basically. And then also they make it easy for users to access the data. So a lot of times what the data steward is doing is they are trying to take all this knowledge that they have about data and they'll place it into like a data catalog. And so what's a data catalog? A data catalog essentially is just a program that stores like the metadata, like that knowledge that the data steward has, so that you don't have to actually ask the data steward. You can just go to the data catalog and say, oh, this field is representative of this type of information, and it has this kind of timestamp. It's collected monthly, and it's collected for these particular portions of the world, or so the data catalog just kind of stands up all that metadata, that rich information that lives in the data steward's head, so that you don't have to bother the data steward. They can do other things, and you kind of retrieve it and continue to work with it. So what is the skill set for a great data steward? So a great data steward should be able to create policies around data usage. She should be able to curate data for entry into that data catalog, as I mentioned, and great networker. I think being a good networker is important because you want to make sure that whoever's touching your data in whatever context they're trying to use it, that they have the full complete picture of how that data has been pulled together and how you can use it effectively. Let's keep going. Data science. All right, so data science. So data science is really hot right now. Like whenever people talk about like AI, like Gemini or Chat GPT, that's all like data science products, right? So, and they talk in particular, those are like large language models, but we don't have to we're not going to go all down that road. But the idea of like data science is really to extract valuable insights from complex data sets, right? So when you say insights could be many different things, right? It could be like, okay, it could be everything from reporting, like how many cars did Ford sell this month in Atlanta, Georgia? So that's like a report, right? But it could also be, okay, it could be a prediction, like how many cars does Ford expect to sell next month or over the whole course of a year for all the United States, right? So I think a lot of times when people talk about data science, they go to the complex thing, but you can't get to the complexity before you understand like the basics, basically. So anyway, so if we want to talk about insights, we want to extract valuable insights from complex data sets. So what are the responsibilities of a good data science, right? So I think a good data scientist should be able to pull their own data and why do I say that? So if you're a great data scientist, basically you want to be able to understand all the transformations that have happened to get the data to where you see it now, right? So that's what I call the data acquisition and preparation. So like basically a good data scientist should be able to like pull the data together for further analysis. They should be able to perform exploratory data analysis. So what does that mean? Like that basically means examining the fundamental relationships and patterns. So things like, I mean, kind of like, these are like the kind of more statistical, kind of fundamental statistical things, but you could say, what is the average, how much does the average consumer spend on our product, right? That's a kind of exploratory kind of a question that you want to answer. Or how many employees do we have on average at a business that we operate, or, kind of more basic questions, but the kind of like the fundamental relationships. So, I'm trying to think of an example of a good fundamental relationship in a business context. So let me think. So how many users are we, like how many users are touching our our web page, during different portions of the day, during different, and if you kind of time box it, like in the morning, in the afternoon, or maybe over the holidays or things like that. So anyway, all right, so model building. So when we talk about model building, we're talking about being able to select the appropriate algorithms for the problem being solved. So without getting too deep into the weeds, basically like, you have all these different set of tools, which algorithm is basically like a tool that can answer specific problems. Some algorithms are good at clustering, meaning you want to have, so when you cluster data, you're basically thinking of it like this, like what are kind of groups of data that belong together. And the real one of the interesting things about clustering is that, like, you can tell what belongs and what doesn't belong, right? So it's a good way to kind of tell like outliers and all that kind of stuff. Another thing besides clustering you might want to do is I'm trying to have a good example besides clustering. Like I said, like you can make predictions. So anyway, you have different algorithms that accomplish different things, and you want to make sure you can select the right algorithm for what you want to do, basically. Then you want to move into deployment and monitoring. So a great data scientist should be able to integrate their models into production systems, right? So after you figured out what you want to do and how you're predicting these, the number of users you expect to see your website over the next day or next time period or next month, then you want to be able to kind of turn that into production systems. So that's another important aspect. And then finally, you want to be able to communicate or share results with your stakeholders, right? So if you have a great model, but nobody understands what you're doing and you can't explain to the business why it's useful or why it's important to be used, then that's a failure of a data scientist, I believe. So what's the skill set of a data scientist? They should be good in Python and R, good with big data technologies, Hadoop, Spark. Amazon has their own kind of data science operating machine learning kind of area in the cloud. So does Google, I'm sure. And then a real key of a good data scientist she should be able to break down complex problems into smaller pieces. All right, let's keep rolling. Oops, I went too far. All right, data visualization. So data visualization, what is data visualization? So as a consultant, I live by this creed, but basically I say to myself, people eat with their eyes. What does that mean? That basically means that, like, hey, look, the idea is that, like, a picture's worth 1,000 words. Those are the same things. So if you can tell a story with visuals, it's a lot better than telling them with like spreadsheets and just anything else other than the visual. Like the picture is the most easy method for people to kind of understand these different concepts of what's happening. So while as data visualization, the cool thing about data visualization, I feel, is that a lot of people can do it. It's not just like there's not just a specific person with a specific role, but like anytime you basically, let me go back. Anytime you're basically issuing reports, then that's a good case for using data visualization, right? So that means anybody across your whole organization has reports to do. You should be able to tell a great story using Power BI or using Tableau or using Looker, different kind of visualization software, different visualization tools. But let's talk about kind of the responsibilities involved in data visualization, right? So again, there's a feature of like data engineering, just like it was for the data scientist and the data engineer. You want to be able to pull the relevant data together so you can analyze it, right? You want to conduct exploratory data analysis. What are those fundamental relationships? A lot of times people, when you were talking about reporting, it's really about the fundamental relationships and patterns. And critical thinking, I think critical thinking is often underutilized for data visualization because you're working with so much data, you have to think critically about what is the only data that I need to use to make my case or to tell my story about the business or to the business, right? So you want to basically, the thing is, like, you don't want to overwhelm people, which is very easy to do. And to give just the relevant information takes a lot of critical thinking. And then you should also be, as a skill set, you should be knowledgeable in some of the tenets of visual design, like layout and color theory, which I'm sure as you guys, as front-end developers, are probably much more familiar with than me. And you want to have great attention to detail and effective communication. So that is, from a high level, the kind of my understanding of like the 5 different areas in data analytics. And with that, I would want to just say I want to kick it open for questions now. Anybody have any questions for me? Let me come back and stop sharing so we can come back and see these wonderful faces. All right.
Hello.
Yes, Nini, excuse me, I apologize.
No worries. Can you guys hear me properly?
Yes.
Amazing. So first of all, I'm a newer graduate from software engineering, so I've been trying to understand a little bit more about how to use databases in order to be able to create better solutions.
Okay.
I specifically have used relational databases before, but I'm always was curious because that's kind of what they show us on the course that I was taking. Then, which occasions are better to use a relational database and which occasions are better to use a non-relational database when putting together a solution?
Wow, that's a good question. I mean, let me think about that. So it depends. A lot of times it depends on like if you're trying to collect information and it's kind of a more kind of changing nature, like the fundamental units of that information are kind of be changing and not necessarily all the information will be present, then you kind of would want to, I think that would suit you to more of a non-relational database, basically. So that's a very high level. I know it's kind of
Mhm.
like as I've done, I mean, so I'll tell you this way. So the interesting thing is like, so I've worked with MongoDB, which is kind of a
Mhm.
leading non-relational database. And
Mhm.
it's interesting because many of the things that I was doing with MongoDB, I could have done in a relational database, right? So what I'm trying to say is there's a
Mhm.
lot of overlap between the two. It's not just so a lot of it goes to like performance, especially when you're trying to query those like documents or like the documents that are kind of like ragged, if that makes any sense, Nini.
It
Hopefully I answered
does.
your question. Okay, cool,
No,
cool.
yeah, it does actually. Oh, and like a little bit of like a side question, and I'm so sorry, I'm Sarah. Is there any specific resources that you really like for people that are beginning to understand in databases?
Good question. Let me think about. You know what? What I'll have to do is let me get back to you. Let me think about where I started learning about this information, and I'll send you I'll put an email or get to go through Maria and send you some information about what because I'm trying to think like off the top of my head. I mean, I learned a lot of it just by I'm really about hands-on learning, right? So if you
Mhm.
could open up like I'll say it this way, go ahead and download like MySQL or maybe even a free version of SQL Server, you know what I'm saying? And just play with it. Like they'll have some default databases in there. You can maybe even load up some of your own stuff, but you want to just play around with it because that's like the most that's like what's giving me the most that's where I learned the best from actually like downloading the software, playing around with it, and trying to answer questions. Now, I do have I'm gonna and I'll put you some good resources in later in the chat. I gotta go ask around a little bit though. Okay.
No worries. Thank you so much for answering.
No problem. Thank you for your question. All right, Ansar, I think you are next. What's your question?
Hey, yeah, my question was actually fairly similar to, I believe Nini's question, but yeah, I come from an engineering background, but different, whatever. And I've been a stay-at-home mom for a few years and kind of getting back into work. And I think just hearing the breakdown, I think I resonate the most with like, just a desire or interest in becoming or thinking about data science, being a data
Okay.
scientist and just wondering, especially as someone kind of getting back into the field after a hiatus, just what type of resources would you recommend? Are there internships or apprenticeships available versus the non-traditional going back to school route?
Yeah. Okay. So the tough thing is, I like off the top of my head, and I may even let Sundar give his opinion on this, but off the top of my head, I don't know of really like the internships. Like the internships, well, I don't know of a space for internships, which I think is a great what am I trying to say? It's a disservice to the industry because they think like when I think about data science, a lot of times it feels like they want you to kind of be fully able to go like out of the hat. Like, what am I trying to say? So I'll say it this way. Basically, in my experience with data science, like the pathways to becoming a data scientist aren't very clear. So they come from many different fields. Sometimes, I mean, it's kind of heavier on the math background. So I think as an engineer, you kind of got that covered. But at the same time, like you can kind of get into it many different ways. So what I would say is No, I will do this. Let me think about your question in particular, because I'm trying to think of like internships are like in my experience, I haven't seen too many data science internships, you know. It's usually like a particular problem that the company's trying to solve, and they turn to a data scientist for it. So I don't know. I don't know how I don't know how good of an answer that is, but I can definitely give you some more resources too as well. Like in particular, there's this one that I subscribe to, which is called machine learning. Let me just bear. I got it. I can pull up an email. I'm gonna hold on. Is my screen still sharing? Yeah. No, it's not. Okay, let me do this. I'm gonna find the resource that I use for my machine learning stuff. I think it's called Machine Learning Mastery. So what I will do is, let me see if I can put this in here. He basically, I like this guy a lot because he kind of tells you like, he kind of lays it out two ways. Mostly all this stuff is in Python. So I would definitely like brush up on Python, but he's going to give you like, he's got a lot of great like introductory stuff. Hey, this is your first time being data scientist. Let's learn about Python. Let's learn about some of these different algorithms. What are the, from a conceptual kind of standpoint, what can they do? So I just want to see if I can get where I can get to his website. Let me see here. Bear with me, Sarah. I mean, so I don't think his stuff does cost a little bit, but it's not too expensive. Let me see here. I just want to go to his where is his page? All right. All right. So what I'll do is I'm gonna put this link in there. This is the guy that I like a lot. Let me put it in our chat here. Thanks for bearing with me as I found this. So I think that should be a link to an ebook that I like. But what I would say is don't just start there. Just go to his website and look at a lot of his different look at all his different offerings basically. Because as far as I found, I think he's done the best job of introducing the concepts, what you need to know, what you're doing with each step, and it's all done in a very great kind of like using Python basically. So that's where I go. So that's what I would tell you. Okay. Can you see the link? Is it working for you?
Yes, thank you.
Wonderful. You're very welcome, Ansara. Hey, Sundar, what's your question, my friend?
Hey, Linje, thank you for the session. Very helpful, right? Informative. So just a little bit of background, right? And so I originally came from distributed systems, web applications and Windows and everything, right? So data is new than in the current job. So a couple of questions, right? This is actually also, we have this challenge in the current project, which I'm working on. So I know you mentioned about the data privacy and security, right? In terms of protecting sensitive data. I have one question, like what are some of the recommended approaches in the industry that is, widely followed for data security? Let's say we have SSN or password stored, right? We always struggled with that one, there's, do we encrypt it? Do we hash it? Like, what are the recommended approaches?
That's a great question, Sundar. You know what, my friend? I mean, let me think. So, I mean, to be honest with you, Sundar, I haven't done too much like data security stuff. You know what I'm saying? Like, I can tell you at my current client what they are doing. So, I mean, at least in their environment, they're using these things called like basically like key tabs. So they provide hold on, let me think. How can I explain this, Sundar? Just a minute.
Yeah, sure. Thank you.
All right, yeah, no problem. So basically, as I understand it, Sundar, what they're doing is they are essentially like encrypting, they are allowing users to create files which encrypt their passwords. So what am I saying? So let's say you are trying to like authenticate against a server to run some queries or something against like their Hadoop file system, right? So what they'll do is basically like instead of, I mean, they have kind of like they have like a web UI where you can put in your password. But if you want to run heavier queries on the back end, what they're doing is essentially like allowing you to create like a key, like a file, which essentially stores your password, and then you reference that when you're running your query. So I think that's a pretty elegant solution, but there are still some holes in it. Like, so, I mean, so now we might have to take this offline a little bit. That might be a little out of the scope of my expertise, but that's kind of that's kind of what I've seen essentially that I think works pretty well, especially if you're like trying to, especially like in the engineering level, not just like doing stuff through the web user interface. Does that make sense, Sundar? You see what I'm trying to say?
Yeah, absolutely.
At all?
Yeah, thanks, Linje. Actually,
Okay.
yeah, we can take it up offline because this is one area, I mean, in our team, we always have struggled because we store a lot of sensitive data, right? So that's
Yes.
okay, how do we do it, etc. So
Yeah.
Linje, second question, again, this is also, me coming from the distributed, right? So I always
Okay.
get, have not much clarity on like a data engineer versus data scientist, right? Data
Okay.
engineer, based on what you explained, it's pretty straightforward, right? They build pipelines and whatnot. Data scientist
Yes.
is their main role to build models and forecasting. Is that the primary skill set of a data scientist?
I think so, Sundar. As I see it, I mean, like, here's the thing. It's weird because I'll say it like this. Yes, the primary role of a data scientist is to use their knowledge of different algorithms and techniques to accomplish the business objective. So if they want to predict something, or if they want to, like I said, cluster something, or perhaps they want to assign like a label to something, right? So like the thing is, so when I say assign a label, like you have like a bunch of data and you want to kind of classify something. That's the correct terminology, right? So like, let's say like basically, yeah, so before I get down to the rabbit hole, Sundar, so you're right, like they're distinct from data engineers, like they work with data engineers, but often they're asking the data engineer to like feed them the data, in a particular format so that they can apply their models, because a lot of times models have they're like, these algorithms are very particular in how they take in the inputs into the input stage of like of their predictions or of whatever, of the clustering or of the classification task. So whatever the algorithm requires, you have to kind of transform your data to get into the proper format, and they call that transformation into the proper format. They call that feature engineering. So a data scientist takes the features. I mean, I think a good data scientist should be able to do his own feature engineering, but oftentimes that's not the case. I mean, you can save time and go faster. A lot of times you can hire a data engineer or work with a data engineer, but I like to do the feature engineering myself. But anyway, so we'll let that go. So so they take the data and then they're going to apply all their different models, techniques, regression analysis or neural networks, or like whatever large language model. They're gonna take the algorithm, apply that to your data, come up with the result. Then they should also be able to take that result and plug it back into your production systems. Does that make sense? So
Yeah.
that's why I draw the distinction between a data engineer, like they work with data engineers, there's overlap, but they should not. But the data engineer should kind of stop at some point and should be picked up by the data scientist who's more expert at like kind of understanding like the math, not necessarily the math, but like what's happening under the hood of the algorithm and how to select the best algorithm to do the job. Basically, that's how as I see it. So that's where I would
Got it.
say.
Yeah. Got it, Linje. Yeah, because that's, we don't have data scientists in our team, but we always
Yeah.
confused. Okay, what do they actually do? Yeah, that helps. Thanks.
Yeah, so and someone just has put a question in the chat. So let's see. So they were using they had this thing called key tab. I mean, so I think it was basically like I think it's another version of like a key file basically. But again, like I don't want to get too far into it because that's not my area of expertise. I'm not necessarily I'm not the security guy that much. I kind of just make sure I like after they have it all set up, I come in. So, but I know that security is always a feature, should always be considered, especially by the data architects. So anyway, that's that. All right. Any other questions? These are great questions.
Yes. Linji, we do have one question from Molly. How do you measure the effectiveness and maturity of a data governance program?
Ooh. All right. The effectiveness and maturity. So as I said earlier, like, all right, well, okay. I'll say it this way. I'll start from this standpoint. Like the effectiveness you can measure a couple of different ways. When I like to think about it, like especially from a data governance perspective, let's see. So you could look at it a couple of different ways. You could say, okay, if you believe in data catalogs, which I discussed earlier, which is this concept of how much you're basically saying how much and how much usage are we getting out of our data catalog. So in another way, what am I trying to say? So let me remind everybody what a data catalog is. The data catalog is what stores your metadata, like your information, right? So So the better your metadata is curated and accessible and understandable in your data catalog, then naturally the more users are going to be, the more your users are going to be looking to that information to make their decisions, to use the data in however manner they want. So I'm a big believer in data catalogs because it forces you to do a lot of different things. It forces you to first think about, from a standpoint, before you even put the information in, you have to curate or collect that information, understand it. Then, so the process of just standing up a data catalog is a great kind of thought experiment for any company to do. So, I mean, but from a maturity standpoint, do they have a data catalog or not, right? And then if they have a data catalog, like, what is the usage? Like, you could, I mean, just like a lot of these are like web-based, like they're basically like web-based programs. So you could look at different, like, how many people are pulling down information from your data catalog. Now, there are other concepts involving data governance, like we can talk about it from an organizational standpoint. So data catalog is a tool, right? But you also have to stand up like processes in your organization that are going to address security or things like basically like quality checks, right? So basically when I talk about the processes and the kind of organizational structure, I'm saying like, your data stewards, do they roll up, like where? So you have a bunch of data stewards for different types of information, right? So let's say you're at a business that sells cars, right? So you maybe have a data steward for your customers that they're going to learn everything about your customer data set. You have another data steward for your cars, like your inventory, like the different cars. Maybe another one for, different. So you kind of, basically the idea is like you have a data steward that aligns to different types of data. But the concept I'm trying to convey is like, okay, well, how have you structured your data stewards so that you get the most out of this knowledge, right? So that the company is aware of what they're bringing, how they can help each other. Are they basically integrated into your company's kind of data landscape, basically, for lack of a better word, right? So, without going too much into the details, you could say like, has the company taken a mature route, or more mature route, or less mature route to the usage of how they're structuring their data stewards and how they're integrating into their business processes, right? So, maybe the data stewards are separate from the business processes, or, they're like siloed. So you don't want that. You want them to be integrated, basically. So trying to come back to your original question, I mean, there are some metrics I looked at a while ago for data governance, but that's probably a separate conversation. So I'd have to go back and dig up some stuff I did, but I can send you what I did on that. I have no problem. So, but that's what I think about like maturity, like how good are you at using the tools, and how have you integrated, how have you set up your structure, your organizational structure to leverage the knowledge of data stewards, basically. So that's what I would say. I mean, those are kind of along those continuums are, you put many different companies. So anyway, thank you for the great question. Tough one there. Tough one. Made me think a lot. Thanks. All right.
Thank you,
All right,
Linje.
Molly. So, yeah, no problem. Go ahead, Maria.
Thank you. I don't think we have any more questions. I do want to say thank you so much for the amazing session. Hands down.
Sure.
I learned a lot. I'm sure everybody of the participants as well. If you want to contact Linje or connect him on LinkedIn, he's going to share also the resources. So please do join us on a Frontend in Slack. Thank you so much for sharing your thought process and your experience with us. Linje, was amazing to have you as a speaker. And if you miss and you want to watch the video, we're going to have a recorded session.
No problem. Well, I just want to say thank you, everyone. I've had a great time. So I can come back, but I probably talk about the same stuff again, and I don't want to bore you. So I just want to say thank you for having me on. I really appreciate it. I appreciate all the great questions, very thought-provoking questions. And I think, what I wanted to accomplish was just kind of, allow you to understand when people talk about data analytics, what are the different fields, and, maybe some things you could even be involved in as you grow in your career. So hopefully I've accomplished that. And thank you again to Maria and to Violina and to Anna for inviting me. And I look forward to sharing my resources. And if you have any questions, please feel free to reach out to me on LinkedIn. Thank you very much.